Hello, welcome to this video. Today we're going to look at this problem. So, we are given 5 prime numbers that are not 2 or 3, and we need to show that no matter which prime numbers there are, as long as they're not 2 or 3, we can always choose 2 of them, such that the difference between those 2 is divisible by 12. So, the first thing we're going to do is how we're going to use the fact that they're not 2 or 3. So, every number, including all the prime numbers, are congruent to something mod 12. Any natural number has to be congruent to anything mod any other natural number. So if you choose a prime number, it can be congruent to 0, 1, 2, 3, and so on until 11, mod 12. So mod 12, we have 0, or 1, or 2, or 3. Okay, so the list of all the congruence is mod 12. And next, because they're prime numbers, they can only be divided by 1 or themselves. Meaning that if they're not 2 or 3, they cannot be divided by 2 or 3. So because 12 is divisible by 2 and by 3, we can rule out all of the congruences which are divisible by 2 or 3. Because they'll give us that a prime number is divisible by 2 or 3. And that prime is not 2 or 3. So 0, 2, 4, 6, 8, and 10 are ruled out for 2. And then 3 and 9 and 6, but it was already by they are ruled out by 3. 6 was already ruled out. And finally, that gives us these congruences: 1, 5, 7, or 11. Or, to make things a bit simpler, okay. So, these are all the congruences that we have for 12 left: 1, 5, 7, and 11. So, all the prime numbers, which are not 2 or 3, have to be congruent to one of these 4 mod 12. So now let's look at the actual problem and solve it. So say we're given 5 prime numbers. We'll loosen that a bit to what we just found, and we'll say we're given 5 numbers which are congruent to one of these 4 numbers mod 12: 1, 5, 7, or 11. And now we need to show that we can always choose 2 of them, such that their difference is divisible by 12. And this will work for prime numbers too, because all prime numbers are in the list of numbers congruent to one of these 4, except 2 and 3, but we're not talking about those. So, let's see. So, let's use our loose list of numbers. So, the most different numbers we can have mod 12, different congruences we can have mod 12 for these numbers are 4, because that's by definition they can only be congruent to 1, 5, 7, or 11 mod 12. Meaning that no matter what, there's going to be the 5th congruence, which will be the same as another one of the 4. We can have 5 different ones by definition. Meaning that we can always choose the last number together with the pairing the pairing number which we have in the first four. And if the fifth number does not have the same congruence as any one of the other four, that means that the same rule had to apply just in a different order. So any two numbers will have to have the same congruence mod 12, meaning that when we take their difference, the difference will be divisible by 12. Okay, now let's look at an example of this problem just to make things more clear. So let's pick 5 prime numbers. We'll do 5, 43, 17, 29, and 11. So, by this problem, all 5 of these should be congruent to 1, 5, 7, or 11, mod 12. So, let's look at these mod 12. 5 stays 5 mod 12. 43 mod 12 will be 7. 43 minus 36. Next, 17 will be congruent to 5. 29 will also be congruent to 5. And 11 will be congruent to 11 still. And now you can see we actually have more than one pair that are congruent to the same number mod 12. Meaning that when we subtract them, we get a number which is 0 mod 12, aka divisible by 12. So in this case we have 3 pairs, which are this, this, and this, which correspond to 5 and 17, 5 and 29, and 27 and 29 and 17. So that's pretty much the whole idea of this proof, and that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more things like this in the future. And finally, that's it.